Hello and welcome back to the final part in our quadric surface series. Today we will be going over the hyperboloid or the hyperbolic paraboloid. This is the sixth and final shape. Once again, I want to remind us one last time exactly what a quadric surface is. Quadric surface is a graph of quadratic in three variables, x, y, and z. And our strategy for graphing these is plotting our intercepts, plotting our traces, and completing the picture. We've gone over ellipsoids, elliptic paraboloids, we've gone over elliptic cones, hyperboloid of one sheet, hyperboloid of two sheets, and finally hyperbolic paraboloid. Oh man, say so much Alec Lloyd, it all kind of blends together here, but I digress. Let's go ahead and get into the general equation here. Wrote it in red because this is the one that I'm scared of. Graphing this baby is going to be awful, very complicated, but we're going to get it done regardless. General equation, z is equal to x squared over a squared minus y squared over b squared. Without further ado, we're going to go ahead and get into our example here. We are asked to graph z is equal to x squared over 16 minus y squared over 25. Oh man, you may be noticing something different here. Our y is pointing in a weird direction. Our x is pointing in a weird direction. We essentially rotated our three-dimensional graph. I don't even know what that is, but we rotated it, okay? We switched our x and our y, essentially. Why? We will see very soon exactly why we did that. It's going to be evident when we draw the picture. If we did it the other way, then it would be extremely difficult to draw. This is just as a convention thing. So yeah, let's just go ahead and get into it. Let's go ahead and write down our strategy here. We are going to want to plot our intercepts. We are going to want to plot our traces. Lastly, we are going to complete our photo. Let's go ahead and do our intercepts first. We are going to have our x-intercept. X-intercept is when our z and our y is equal to 0. Well, we can just see x squared over 16 is equal to 0. Our x-intercept is 0. Y-intercept, x and z are equal to 0. We have y squared over 25 is equal to 0. Y is equal to 0. And then we have our final intercept, our z-intercept. This is going to be the last intercept that we find. X squared, y squared is 0, z is equal to 0. So our intercept is going to be at the point 0, 0, 0 at the origin. We'll do that in red. There we go. Oh yeah, 0, 0, 0. Looks good. Alrighty. Time to plot our traces here. So we are going to plot our xz trace first. I believe I do that in green. I always forget. I don't know why. I just can't. It's when our y is equal to 0. So we have x squared over 16 is equal to z. Pretty simple. That's just going to be a parabola, as we can see. We're going to do our yz trace now. When our x is equal to 0, we have negative y squared over 25 is equal to z. Negative y squared over 25 is equal to z. Yet another parabola. And our final one, we're going to do in pink per usual. We have our xy trace. But let's be real. It's going to be a z equals z naught trace. Xy trace, x squared minus y squared equal to 0. The only thing there is 0, 0, 0. Doesn't work out. So we have, I'll just write it out. X squared over 16 minus y squared over 25 is equal to 0. That's just going to be 0, 0, 0. So we have our z is equal to z naught trace then. Let's do it. Okay, so you really have to just recognize that this is a hyperbolic paraboloid, essentially. So there's essentially three sections to this graph. Okay, so we have one section. Well, let's go ahead and just do this first. Is x squared over 16 minus y squared over 25 is equal to z naught. So we have essentially three different options here. So number one, if our z naught is equal to 0, then it's just going to be 0, 0, 0. Okay. But we'll just solve the equation up there. Okay, so then we're going to have, what is this going to be? X squared over 16 equals y squared over 25, square root of both sides. We have x over 4 is equal to y over 5. Multiply that 5 out. We're going to have y is equal to positive or negative 5 over 4x. I'm not going to show the work there, just for the sake of I've been doing it the whole series. Number two, our second case is when our z naught is greater than 0. And if that is the case, then we get what? So if it's greater than 0, then we essentially have that hyperbola that opens in the x direction. So let's just write that down. Hyperbola opens x. And our third case is if z naught is less than 0, then our hyperbola opens y direction. So pretty much what I'm trying to say here is that we'll see this is if it opens in the x direction, then let's just say this is the x-axis right here. Well, it's going to look like that, right? So now in our third case, wherein we have our y-axis here now, we're going to have bang, bang. Okay, so I think we can start to visualize why this is going to be a pain to graph, essentially. So we're just going to get into it. Honestly, it's going to be difficult. It's going to look bad, and I'm completely fine with that, but that's okay. So first off, we're just going to go ahead and start in order. We're going to do our x, z trace. Purposefully did this one first because this kind of sets it up for it. We're going to start right there. Bang, bang. I don't like that. I don't like that either. Let's see, can I get it to correct to something pretty or no? Oh, man. You know what? I revived it. We're using it. Just imagine that it's better, okay? Okay, that's our xz trace. That is our only one right there. It's only going to be positive. Okay. Now we're going to go ahead and we'll do our x is equal to x naught trace now for the positive z. Those are going to look like hyperbolas that open in the x direction. So like I stated prior, it's going to open like that. Okay, so we're just going to go ahead and connect the dots here. I'm cheating a little bit by showing like the math behind it, but there we go. You know what? This is actually starting to look pretty good actually already. Okay, we have that. I'm almost suspicious to I guess we'll do the other, the YZ. Yeah, we'll do the YZ now. So in the YZ, we're going to do negative y squared over 25 is equal to z, meaning our hyperbola is going to be down here. It'll work. It'll work. So now we're going to do our other z naught trace here. Hyperbola opening in the y direction, meaning we're going to have something like that. So we're just going to connect the dots. Oh, man, I messed that up. Screwed that up. Okay. That's okay. Now we're going to fill in the dots here. This is going to connect to that. This is going to come down. Come all the way down here. And then we're going to come... Oh, well, actually, not quite. It's going to come down to this right here. It's going to come all the way back up there. I warned you that was not going to be pretty. Oh, man. This is not ideal. Never mind, that's going to go up here. It's very bad. It's not great. I tried to connect the dots as good as I could, but it just didn't work out. I apologize. Like I said, I am not good at drawing this shape at all. We get the idea. Luckily for you guys, I did in advance draw a pretty good one. So as you can see, I think I went wrong right here. I went wrong right there, but this is what it looks like right here. Okay, so this is the X, this is the Y, this is the Z. Okay, I'm going to get rid of those just so we can visualize it better. But essentially, this right here, these right here, I'm going to make this thicker. These points right here, these hyperbolas are when our Z naught is greater than 0. And these hyperbolas right here are when our Z naught is less than 0. Okay. Our XZ trace is just going to be, I think, what was that, yellow? Green. Our XZ trace was supposed to be right here. This is what I was saying. It started off pretty okay. And then our YZ trace is going to be right here. And essentially everything else is just kind of like fill it in, right? So then we just have that. Yeah. So that's essentially what it is. I mean, I didn't execute it well enough, but realistically, as long as you get the idea across about what it is, you should be fine, because I don't really know that anybody's expecting you to draw this to a professional level. Essentially what this kind of looks like is it kind of looks like a Pringle, like a chip. You know what I'm saying? It's called a saddle. Okay, that's kind of what the informal name for it is. The like I said, the formal name is just going to be a hyperbolic paraboloid, but realistically, you can think of it as a Pringle. So, I mean, if you really just have a Pringle chip in your mind that's like super curved, then maybe you can draw it pretty well. But, I mean, I personally am not great at it. So, I apologize dearly for that. But that's going to be the end of our quadric surfaces. We found and graphed all 5 using our strategy of plotting our intercepts, plotting our traces, and completing our picture. One more time. We have our ellipsoid, our elliptic paraboloid, our elliptic cones, our hyperboloids of 1 sheet and 2 sheets. And we finally have our saddle, or formally our hyperbolic paraboloid. That is the end of our video. Thank you very much for learning quadric surfaces with me. I hope you tune into the rest of my videos on Calculus 3. Thank you very much.